next speaker is Professor Dr. Clara Mancini. I met Professor Mancini during COVID times about a few years ago when I was at Wageningen University. Dr. Clara Mancini is a trailblazer in the field of animal-computer interaction and serves as a professor and head of the HCFAI laboratory at the Open University in the UK. I'm inviting Dr. Clara Mancini to share her slides. Her innovative research delves into the dynamic interaction between animals and technology, aiming to enhance animal well-being and foster meaningful relationship both within and across species. Dr. Mancini's research is multifaceted, groundbreaking, of course. She studies how animals interact with technology in their natural environments, whether the interaction is direct or indirect, active or passive, synchronous or asynchronous. Her work is dedicated to developing animal-centered technologies that not only improve animals' well-being, but also support their activities and enhance intra- and interspecies relationships. By advocating for transdisciplinary animal-centered approaches, Dr. Mancini enables animals to be legitimate stakeholders and active participants in the design process. She has led numerous pioneering ACA projects. For example, a while ago, she was working, developing some interactive enrichment for captive elephants, communication systems for medical detection dogs, ambient interfaces for mobility assistant dogs, wearable animal biotelemetry, and many more. She's so passionate about the methodological challenges and innovative opportunities within the ACI domain. In addition to her research, Dr. Mancini chairs a teaching module on interaction design and the user experience, further enriching the field of animal-computer interactions. So in the intersection of technology, animal well-being, justice, human-animal relationships, spanning theory, methodology, practice, and ethics, Dr. Mancini is committed to informing the development of equitable, sustainable, and inclusive multi-species ecosystems, both natural and artificial. So glad that Dr. Mancini was able to accept our invitation to share her knowledge and wisdom and experiences. Very warm welcome to Dr. Mancini. The floor is yours.
Thank you so much. Can you hear me okay?
Yes, we can hear you, yeah.
Excellent. Thank you. Thank you so much for this kind introduction and for the opportunity to participate in this important event. I am sorry that my work hasn't been in the farming context. But hopefully what I am going to share might be of relevance, you know, for this event. I would like to start by say that a lot of the work that I'm going to present today is the result of collaborations. And so the colleagues that I've worked with are acknowledged along the way. So animals, as we know, have been exposed to computing-enabled technologies for a long time and are now increasingly impacted by emerging technologies such as the Internet of Things and artificial intelligence. However, the design and deployment of most of these technologies still prioritizes a human-centered perspective. So in contrast, the growing field of animal-computer interaction, or ACI for short, focuses on the nexus between animals and computing technology from an animal-centered perspective. So in particular, the Open University's Animal-Computer Interaction Research Program was set up in 2011 on a mission to advance the art and science of designing animal-centered interactive systems for a participatory multi-species society. I'm just mentioning this to stress that we take a very sort of multimodal, multidisciplinary approach. And so what I hope to contribute today, hopefully, is something to do with the design, the perspective of designing the technologies that might be deployed in farms, but obviously using examples from work that we have done, which was outside of that context. So specific aims of the HCI lab are to investigate the interaction between animals and technology within their habitual context, to design computing technology that improves, hopefully improves animals' welfare, that can support animals in their activities and foster intra and interspecies relationships. And I'm personally also very interested in informing animal-centered approaches to developing technology for and with animals as legitimate stakeholders and design contributors. So when we talk about computing technology, we more often than not deal with systems that have both tangible elements, such as software and data, and intangible elements, such as software and data, and tangible elements, such as sensors and actuators. Animals are affected by both in different ways. For example, more indirectly, they are affected by algorithms that influence humans' behavior towards them and all the biases that may come with them. But more directly, they are affected by the physical interfaces of computing systems with which they come into contact. So we need to consider both high-tech and more mundane aspects of developing and designing technology. So additionally, when we talk about animal-centeredness in relation to the design of these technologies, we need to consider the design solutions themselves, the research methods employed to develop animal-centered technologies, and the wider implications related to the socioeconomic systems within which animal-centered research and design are conducted. So with this in mind, for the remainder of this presentation, I will try to provide examples of how we have approached the design of animal-centered computing systems. So to begin with an important thing that needs to be considered is to try and minimize the physical impacts that technological devices can have on animals. For example, biotelemetry is increasingly used to monitor animals for conservation, for research, and husbandry purposes. But animal wearers, the primary stakeholders, have no control over its use. The devices that they wear can interfere with their body, for example, injuring or trapping them, and activities, for example, slowing them down or disrupting their camouflage or other activity patterns, thus reducing their welfare and the quality of recorded data. Also, guidelines informing the design of these devices are still tend to be rather coarse and ad hoc. So to address this issue, this project investigated how to minimize the impact of biotelemetry by improving what we call wearability. So in particular, we adapted values and principles informing the design of human wearables to develop a framework that could support a wearer-centered approach to the design of biotelemetry. The framework is underpinned by the fundamental values of non-deleteriousness and minimization of effects, and by 3 design principles stating that the presence of tracking devices on the animal's body should ideally be imperceptible, or at least unobtrusive, or at least cognitively acceptable to the wearer. All stakeholders should be considered, primarily the wearer, but also what we call their significant others, for example, social relations such as mates and offspring, and asocial relations such as predators and prey, and of course, human users. Whereas biological characteristics, their activity, and their environment should all be considered, and all possible design variables, along with technical variables, should be exploited to maximize wearability. The example on the right here suggests that when designing a tracker for red foxes, for example, the device should not emit background noise that is within the hearing range of the fox, but also of her potential prey and potential predators. And this is just one aspect to consider, and there are many more. So as a case study, Patrizia, the doctoral students work on this, conducted ethological observations of cats wearing different commercial GPS trackers, which showed poor wearability, even though these were marketed as cat-friendly. In contrast, ethological observation later on down the line of the same cats wearing a tracker that was redesigned using the same electronic components but applying the framework showed significantly better wearability. But beyond physical impacts, we also need to be mindful that these technologies collect and process animal data that is then acted upon, which raises the issue, among others, of animals' privacy. So, and I'm not talking about the farming context, of course, which is a very specific one, but in general, if we think also in the wild, for example. So privacy is a fundamental multi-species need which animals manage by employing a wide range of distance setting and information filtering mechanisms to ensure personal safety, to maintain territory, to access resources and mates, and to regulate social relations. So in this project, we sort of made the case that when designing technologically supported environment, protecting animals' privacy should be a serious consideration. And in fact, it should be a design goal, or at least as far as possible. On the one hand, we argue that we ought to balance our wish to gather information on animals for their care and protection and the animals' need to preserve their privacy for, principally for safety reasons, but for reason of managing their resources, etc. So in this regard, so for example, if we think about augmented reality and location-based applications, this could be deployed to educate the public about animals' privacy needs and why they need to be respected. These need to be respected. While, of course, data aggregation and filtering mechanisms, such as information blurring, could be leveraged to avoid disclosing animal-sensitive information. For example, the precise location of an activity times, particularly for sensitive activities. And naturally, security mechanisms, which usually are in place, such as selective access and encryption, need to be employed to keep generated data secure and prevent ill-intentioned behaviors such as cyber poaching, which is becoming a real issue in the wild. On the other hand, now, where animals live in artificial settings, wouldn't it be great if these could enable them to manage their own privacy boundaries? So in this regard, for example, could we envision adaptive interventions that could be designed to recognize and respond to animals' detected states and behaviors, such as signs of stress, to allow them to influence their environment? And better still, could interactive environments be designed to allow animals to access, traverse, and even reconfigure spaces at will by removing, erecting barriers to seek seclusion from or inclusion with others? So regardless of how practically complex this might be, we think it's valuable to think about these things for future development. But in order to be able to control their environments, ambient interfaces need to be accessible to and usable by the species in question. So in order for animals to be able to control their environment, they need interfaces that can access and actually use. So these interfaces need to be informed by good interaction design, which needs to provide good usability and what we call good usability and good user experience. So to this end, a systems interface should present affordances that enable a user to understand how they can interact with it effectively, provide feedback that lets the user know they have successfully provided inputs whilst they wait for the interaction outcome, Affordances, feedback, and outcomes should be perceivable to the user, and associations between affordances, feedback, and outcome should be consistent, and the space-temporal distance between input and output should be minimal. And the interface should not allow users to take actions that are not fruitful by appropriately constraining the interactions. Now, so for dogs who are trained to interact with various technologies on humans' behalf, such as mobility assistance dogs, they have to operate in environments that, from a dog's perspective, contradicts the most fundamental interaction design principles. And this results in poor usability and poor user experience, impacting the dog's training times, performance, and also their welfare. So with this project, we wanted to rethink the way in which ambient interfaces are designed to make them more accessible for dogs. We wanted to develop a portable kit of controls that could be retrofitted in the dog's living and working environment to make it easier for them to operate within it. So to this end, we applied established interaction design principles according to our users' characteristics, including the sensory, such as colors perceivable by dogs' dichromatic vision, cognitive, such as dogs' object categorization primarily by size, and physical, such as dogs' snouts' greater motor control and sensitivity compared to their limbs. We also needed to take into account the context in which these devices need to be used, and specifically the activities, for example, the opening doors, switching lights, calling elevators, actioning traffic lights, and the environments in which these activities take place. For example, the domestic and urban settings that dogs share with humans. So our research shows that input devices designed according to these criteria make dogs' tasks much easier. Here is just a little example of me, sort of just showing my dogs how to use one of these controls. But first, I just wanted to say that this doctoral student, Louisa, who worked on this project, she compared our canine center controls against standard issue access controls for operating a motorized door. And that shows improved usability of the controls that we designed based on parameters such as overall time to open the door, number of contact attempts with controls, and attempts necessary to activate the control. So here I'm going to show you a little video, as I was saying, of just me doing this with my dogs, and just to show you how easy it is. And this is just after a couple of hours of training. I'm sorry, for some reason the video seems quite skippy. So basically a very light touch, very easy for the dogs to learn, and a very light touch could move that big and heavy door, obviously with a motor. So these for mobility assistance dog and for their assisted humans can make a really big difference. And it's all down to designing things in a way that are accessible to canine users. So Louisa then further developed the design of our next generation of wireless cylindrical controls, testing different sizes, push-pad travel distance, and profile. And we found that a control with a convex 120 millimeter diameter and 5 millimeter depth travel pushpad performs best for dogs of different sizes. Moreover, we also found that whilst the concave pads guided the dog's snout nicely towards the center of the control, inviting a more precise interaction, the convex pads actually enabled the dogs to activate the control from any direction, which provided more flexibility regarding their placement in the physical environment. which is critical for usability in small spaces. And this goes to show how small details can make a big difference when it comes to canine accessibility, again, as I was saying earlier. So following further improvements, here's our final wireless prototype, which can be used to activate a range of domestic appliances and which we are currently in the process of commercializing with the collaboration of a company called Ravencourt. So, however, sometimes the problem for animals is not the environment's over complexity, but is that the settings in which they live lack the complexity and simulation afforded by the environment in which the animal had evolved. As we know, many wild animals who live in captivity and who lack the opportunity to meaningfully engage in activity that have evolutionary relevance develop stereotypes. The problem is particularly evident in large carnivores, and tigers are a case in point. In the wild, tigers have extensive home ranges. They spend their time patrolling their territory, foraging, hunting, mating. In contrast, in captivity, they have limited space and vital resources are provided for them on a schedule. So they have no need, no opportunity to engage in activities that would be essential for them in the wild and that would involve meaningful locomotion. They still cover long distances in captivity by pacing in their enclosures, but they are not going anywhere and do not engage in their cognitive capacities as they would in the wild. So research conducted by Care for the Rare, in particular Dr. Jake Vesey, found that locomotion is actually a welfare priority for tigers, which led to the idea of designing a whole interactive environment to provide rescued tigers residing at Four Paws Sanctuary Tierart in Germany, opportunities for meaningful movement. Tierart are in the process of creating a new complex of interconnected outdoor enclosures for tigers. 3 of these enclosures are connected via a large building where our interactive system is soon to be installed. The building will host an interactive maze consisting of 3 concentric irregular rings and a central island. The rings will be connected by 2 diametrically opposed gate systems, which will open and close to reconfigure the space and provide multiple routes to 5 different exits, or from 5 different exits. 3 leading to different outdoor enclosures and 2 leading to 2 different indoor dens. As the tigers travel through the maze, olfactory, acoustic, and visual signals associated with different destinations will guide the tigers around the perimeters and through the gates. At specific points, the gate's configuration will present the tigers with route options, and they will have the opportunity to make choices to reach specific destinations. Infrared sensors all around the ring's perimeters will allow the system to identify the tiger's location and trajectory as they move through the maze, and to dynamically adapt gate configurations and signals accordingly for a seamless journey towards destinations where the probability of finding resources such as food will also be signaled. To our knowledge, this is the most complex interactive system, interactive environment ever designed and developed for animals, and we are really rather nervous about its deployment, but we're also looking forward to installing it in early September, when we will be able to begin working with the tigers themselves to adapt the functionalities of the system to their learning and experience requirements. They will be constantly monitored to see how they use the space and what difference that makes to their welfare. Now, indeed, a tenet of HCI is that designing for animals is best achieved by designing with them. And in this regard, the ethical and methodological perspective with which we approach the process is key. Arguably, existing legal frameworks regulating the involvement of animals in research tend to be fundamentally process-centered rather than animal-centered. For example, not all species are protected. Research does not have to be relevant to subject. Potential harms are to be minimized, but without compromising procedures. Convenience euthanasia is acceptable if conducted humanely. There is no established process to enable animals to consent or dissent to their involvement, and replacement, reduction, and refinement are regarded as the best practice. These did not seem consistent with or sufficient to support animal-centered research and design. Instead, in addition to complying with existing regulations, including the 3 Rs, of course, we follow an ethics protocol grounded in the following 4 principles. Relevance, which means working with animals for whom the technology is directly relevant and beneficial. For example, working with mice to develop an interface for dog would do a disservice to both species. Impartiality, which means protecting all participants in virtue of their role as participants, rather than their characteristics such as age, sex, species, or even levels of sentience. Welfare, which means ensuring all participants' physical and psychological well-being at all times. And here we refer to Professor Stem Dawkins' sort of parameters of health and wants. So that's what we ground our notion of welfare in, but we also include life. And consent, which means garnering informed consent from all participants, including animals. But how do we garner consent from animals? So for our purposes, animals informed consent takes 2 complementary and equally necessary forms. One, mediated consent, obtained from human guardians who know the animal well and understand the implications of their involvement, who have their best interests at heart and the legal authority to decide on their behalf. But fundamentally, we also need contingent consent from the animals themselves, who must be allowed to continually assess a research setup, a situation, and choose what to do, whether to engage or not, and how to engage, whilst appropriate monitoring of any manifestations of dissent should enable guardians to respond appropriately. So in a nutshell, we argue that doing animal-centered research to develop animal-centered technology requires respecting participants' autonomy and safeguarding their integrity by working in contexts that are habitual for the animal, by being unobtrusive and undisruptive of their habitual activities, giving animals control and space for expression, and using only positive forms of interaction. With colleague Eleonora Nannoni, we further developed these concepts for application beyond ACI research, but I will mention that later. So this approach is applied within an interaction design process that is quintessentially iterative and during which design requirements are elicited using a range of quantitative and qualitative data collection methods. Design concepts are produced for selection, then selected designs are prototyped, and then the prototypes are evaluated to identify further requirements. In other words, this is an open-ended process of incremental orientation towards a perfect final outcome that we may never achieve, but that can be gradually approximated through iteration. And it is in this context that animals' ethical involvement becomes participation by informing the design process. As an example, we explored some of the questions surrounding the idea of animal participation by teaching my dog Zina to interact with one of the early versions of the dog-friendly control to open a small door and switch on a light. So this was prior to the short video that I showed you earlier. We did 4 days training over 2 weeks in short sessions with many breaks. The study took place in settings that Zina had visited many times before, where water and resting place were always nearby. We used only positive reinforcement in the form of treats. and Zina was free to engage, pause, or even walk out, which sometimes she did. During the period of the study, Zina was walked and fed normally, so these activities was just an extra on her daily life and routines. So the coming short videos offer an example of how we take input and direction from our participants. I hope these work a bit better than the previous one. So here we are already making progress with the training, which employs the luring method. To help Zina associate her touching the control with the reward, I place a treat on top of the control. So whenever Zina goes for the treat, she simultaneously triggers a control. This which establishes a consistent association between the two events. At the same time, this creates a bias towards snout interaction. Also, to make the opening of the door relevant for Zina, my colleague rewards her through the door when this opens, which makes the opening of the door relevant for her. So once she has made the associations, I only reward her once she has triggered the control. So here I'm trying to persuade Zina now to touch a larger yellow light switching control that is above the small door, which is a much more demanding task due to the control's height. She's done it a few times for me already, and here she does it one more time, but then she refuses to continue, sitting down and looking at me in a begging behavior. So I try to coax her, but that reward is no longer sufficient. Okay, so this is a continuation of the previous episode. Zina still refuses to engage with the light switching control. I could offer Zina a higher value reward to persuade her, but keeping the reward constant tells us that there is an effort threshold that we should not pass. Instead, I ask her to touch the lower yellow door opening control. Despite the bias towards snout interaction that I had previously created, she chooses to use her paw. So it is clear that she understands what the task entails, but elects to do it in her own way. She interprets the task as the action and the action pattern required to complete it. And by rewarding her, I accept her interpretation. So this sequence has a few implications, just as an example, for design that will inform the next iteration. For example, that the control needs to be located at easy reach. This is pretty obvious. But that the pad has to be sensitive enough to respond to snout interaction, which can be very light, and robust enough to withstand paw interaction, which can be very heavy. So, and these are just very simple examples. Now, here's another example. In this project, we were aiming to design an alarm to enable medical alert dogs to call for help remotely in a crisis. Although these dogs are trained to alert their assistant humans to upcoming critical medical episodes, their humans are not always able to respond in time and may become incapacitated, which leaves the dog powerless and in distress. And obviously is very dangerous for the human as well. So the alarm designs needed to enable the dogs to interact with it as autonomous users. To achieve this, Charlotte, the doctoral student to work on this, needed to work with the dogs to understand what features would make the interaction safe, efficient, easy to learn and to remember, which are specific usability goals in interaction design. Having considered various design concepts, this one comprised an electronic module that would trigger a call to a phone line and a biteable tag for the dog to use as an input device connected to the electronic module by a trigger. But what should the tag be like? What should its size, shape, texture, or material be? What kind of trigger should connect it to the electronic module? Should the tag detach when pulled or should it stay in place? How should the system give the dog feedback to let them know that they have successfully raised the alarm? So we had all these questions. And to answer these questions, Charlotte used what we call quick and dirty prototyping rapid prototyping to engage in some sort of physical conversations with our canine users. So she formulated a modular template for a canine alarm consisting of a tag for the dog to use as input device, a block of wood in lieu of the alarm's electronic module, which the dog would care nothing about, and a trigger connecting the two. And in this way, she could quickly present canine participants like in a flow with successive combinations of different tags and triggers. So this sort of dialogue suggested that the dogs preferred a simple and tidy setup, not to confuse them, a detachable tag that worked as a form of feedback, letting them know that they had completed the task, and a customizable tag and trigger resistance depending on the dog's age, training stage, and personality. And here is an example of a canine user in action with a customized tag. Now, so far we have looked at technologies broadly designed to support animals with a focus on their needs, but what about situations in which the stakes for animals are higher? Is it possible to design animal-centered technology when designers operate within socioeconomic systems that are not necessarily animal-centered due to contextual constraints? So, addressing these questions requires us dealing with the wider implications of animal-centered design. By these, I don't mean party politics or activism, but rather the awareness that design is an intrinsically political activity in which decisions are made that change the world and impact different groups of stakeholders. This inevitably raises issues of justice in general and of multi-species justice in particular, which we explored in this project. And this is perhaps one of the more controversial part of my sort of presentation of some of the work that we have done. So in particular, we refer to Martha Nussbaum's political philosophy and her capabilities approach, according to which animals' intrinsic dignity entitles them, at least the sentient ones, to the opportunity to pursue capabilities which they value and which are important for their flourishing. It is worth noticing that the approach does not demand interspecies equality or the abolition of all instrumental relations with animals, but rather it requires the fulfillment of animals' capabilities to an adequate level as relevant to their species, above which interspecies inequalities are not unjust. It also supports respectful practices compatible with capabilities that develop animals' excellences and promote their flourishing. So the capabilities approach to multi-species justice provides, we think, a measure of animal-centeredness that could inform wider considerations when designing animal technology or when considering animals' interactions with technology. Here are some examples of questions that could help researchers assess the extent to which their work is animal-centered and thus conducive to multi-species justice. While some of these capabilities might be incompatible with some animal farming practices, I would suggest that they are still useful as a benchmark to assess the extent to which some practices may be animal-centered, and more importantly, consider where improvements might be possible within the existing constraints. In this regard, among others, we propose 3 strategies to provide, to provoke reflection. So disruption. So this would involve questioning systems, norms, or practices that go against animals' basic capabilities and that designers would like to address. For example, in a recent project, my colleague Natalia Zableska and I questioned whether smart farms of the future might breach animals' entitlement to privacy and non-exploitation, since we found that these entitlements can be argued for by using already existing jurisprudence. So could smart technologies enable farms of the future to secure these entitlement for farmed animals, at least to a greatest possible extent? Reconfiguration would involve redefining design-related frameworks whose current anthropocentric definition legitimizes the dismissal of animals' role in the design process or justifies design outcomes that discriminate against them. For example, my colleague Jussi Letonen and I explored notions of participatory design, proposing a framework to better account for multi-species agency and interest in design processes and outcomes. So effectively recognizing that animals can be taken seriously as design participants, design contributors. And finally, pollination would involve seeking opportunities to enable animal-centered values to influence systems and practices which involve animals, but which are not necessarily animal-centered, to help such systems become more animal-centered. For example, with my colleague Eleonora Nannoni, we have been exploring the extensibility of ACI's animal-centered research ethics to all animal research. And we have developed an ethical review framework that integrates the principles of relevance, impartiality, welfare, and consent for the iterative refinement of research protocols involving animals. One example of how these strategies could be applied is by reinterpreting, or, to sort of, again, we are in the spirit of provoking reflection and, speculating on future possibilities. But one way is to, for example, reinterpret human-centric governance ethical frameworks from a multi-species perspective to foreground impacts of emerging technologies on animals and raise animal-centered ethical concerns. For example, what if we assess precision farming systems against fundamental principles informing the ethics guidelines for trustworthy AI produced by the European Commission high-level expert group on artificial intelligence? It is noteworthy that the guidelines specify that designers of AI systems should pay particular attention to those who have historically been disadvantaged or are at risk of exclusion, and to situations which are characterized by asymmetries of power or information. So, is there a reason why this description might not apply to animals? Could we envisage farms in the future that are more trustworthy from the animal's point of view? Now, global governance bodies are increasingly recognizing the interconnection among human, animal, and environmental well-being, and the inability of anthropocentrism to deliver sustainability, as expressed by the One Health approach and by the more recent UN's resolution recognizing for the first time ever the nexus between animal welfare, environment, and sustainable development. So consistent with this, arguably, an animal-centered perspective on the design, development, and deployment of computing technologies also in the farming context could significantly support the pursuit of global governance agendas, such as the Sustainable Development Goals. For example, a lot of animal-centered design is highly relevant to this goal. Let's consider good health and well-being, and how animal-centered technology could foster beneficial human-animal relations, support animals who help humans, or improve animal welfare and thus reduce the risk of disease. These benefits would also be relevant for farmers and their animals, as well as the wider society. Let us consider life below water and life on land, and how technology could enable people in conservation activities. By engaging them in such activities, it could enhance conservation efforts and reduce human-wildlife conflict. Again, this could help farms and farmers to play a more effective role in environmental restoration and conservation, which would go towards developing really good public relations and get a better acknowledgement from the public of the role that they can play in society, also beyond just producing food. Or let's consider sustainable cities and communities, and how technology could foster beneficial human-nature connection within urban environments and facilitate social inclusion by involving marginalized groups in urban wildlife custodianship. Similarly, though, if we think of farms as sort of, villages almost, these could also foster more cooperative relations between farmers and the wider community, perhaps encouraging more people to get involved in the custodianship of the activities that happen on the farm, and maybe take a more cooperative perspective. So in conclusion, I guess the question is, how could technology benefit farm animals? And I realize, again, I'm very conscious that the examples that I brought do not pertain to farming, but I'm hopeful that I have, what I shared, I managed to convey some of the sort of concepts and principles and perspectives that could, I think, apply to also the farming context. Broadly speaking, I would argue that in order for these the developing technologies to benefit farm animals, which they should be putting animals, the primary stakeholders, at the center of the design process. And these would benefit down the line as will have ripple effects I believe, on productivity and efficiencies. These technologies ought to focus on the stakeholders' characteristics. So their design ought to focus on the stakeholders' characteristics, their activities, and the environments in which these activities take place, and within the human-animal technology ecology. So a really detailed attention to all the characteristics of all these different aspects. And they should give animals real opportunities to pursue their capabilities consistent with their own welfare priorities. And finally, the design of these technologies should consider the diverse, both tangible and intangible aspects of design solutions, but also the research methods adopted to reach those solutions, as well as the wider implications to keep us constantly reflecting of where these technological development is going. And with this, I thank you, and I'll do my best to answer any questions if there are any.
Thank you so much, Dr. Mancini. It's a fantastic, very, very, you're stirred the pot with lots of questions.
Shall I stop sharing my slides?
Yes. Yeah, you can stop.
Yeah.
Yes, perfect.
So questions
So
in the chat window.
Yeah, if you have any questions, please put them in the audience. In the chat, sorry. I can start off with a question. So first, Dr. Mancini, I think that was really amazing. I'm coming from a human-computer interaction background and came to animal-computer interaction primarily from reading lots and lots of your papers. So I really, really admire your work. So I'm really happy to have you here today. You talked about so many interesting and really practical issues of doing this kind of research, including needing new ethics review frameworks, because if you even do human-computer interaction research, that is challenging enough. But if you happen to want to interact with both humans and animals and you're in a university setting, it's extremely challenging to actually go through the all the proper procedural frameworks you need to go through just to get approvals. So, and sometimes you really wonder whether they're asking the right questions. As you said, they're very procedural focused. are those approval processes really protecting who needs to be protected in that process? So I really appreciate that. One of the things you talked about was the consent process, the informed consent. So coming from a human-computer interaction background, we do lots and lots of training on informed consent, and there are many ways to get informed consents from humans. And that's, as I've come to the animal research side of things, it's something I've struggled with in terms of how do you actually think about getting appropriate animal consent. And so you talked about this particular process you went through for the dog-centered research. Can you reflect on that, the scalability of that? So in my mind, I also have dogs, and there's a long learning curve to training a dog, especially to get them with the treat responses. And does that scale to doing farm animal production level research? I know that you can train them. I mean, milking robots do exactly the same thing. They give them yummy treats to get the cow into the milking robot. But I'm wondering whether you've thought about how that scales and how that type of informed consent and continued consent works for animals who you don't normally have that kind of training interaction with.
So so I'm sorry that I don't have experience with working with farm animals. I guess my point is the point is, what is that the animal is doing when you present them with a research setup? So does the animal have the space to make decisions, make choices within that, whether they want to engage or not, whether they want to walk out, whether they are, there's anything that is relevant to them that is attracting them to engaging with that setting. And I would like to stress that this is by no means a perfect. It's not that once, even if we say, okay, we have these two-part consent sort of forms of consent, we need both of them, and the animals gives us, in quotes, gives us contingent consent. We take it as contingent consent. This is by no means perfect, and by no means we are certain to have that consent. And but is the best we can do. It's about doing the best we can to try and involve animals in a way that doesn't, that is consistent with what they want in that moment. So they cannot address, they cannot, they have no visibility of the wider implications of what they are doing at that moment, which is why we need also humans who have their best interests at heart to acknowledge, to sort of complement that. But I think we still need the animal to be willing to do whatever it is that we hope that they might do. And I would think this could apply to animals in general. It's sort of been used with children as well, to human children, and that's and again, I don't, I imagine when you do research, this is specifically concerning doing research within the design process, at least, and so you will be working with a limited number of animals to begin with. And so this approach, I think, would be feasible. When it comes to deploying technology, again, whether it is possible for animals to decide when and whether to engage and how, that depends, I think, more on the constraints of the processes in which they are being involved. So yeah, hopefully that could be applicable, but that would depend on the context, I would say. I don't know whether I've answered your question.
Yes, you did. Yeah. I think the continual observation of the animal is definitely relevant. And really to understand whether they're what their mindset and what their state is continuing through the research. Thank you. We have a question through the chat.
Yeah.
Emily Carrington, is asking, have you or others doing this research noticed changes in how you see animals or a change in how you view life in general as you learn more and more about communicating with animals? Does this communication with animals improve human quality of life as well as animal quality of life?
In my experience, what is done to me is to make me far more attentive to those we might consider other. I think if we are more attentive, this can help animals. It makes us perhaps better, more responsive. One thing that I really like about the work that we are doing is that it's very humbling. When you want to work with an animal and you want to put the animal in control for, you want to, as much as possible, you really want to try and, you have to really try and listen, and you make so many, we make so many mistakes and so many misinterpretations, and animals surprise us all the time. And do unexpected things. And I personally find this, as I said, quite humbling, but also very enriching. And I think that paying attention, although we may misinterpret things, paying attention is surely better than not paying attention. And so the practice of designing with and doing all we can to design with and do research with rather than research on is I find it very I think that it does change the outlook on life in general. It awakens us to the richness of other and sophistication of other living beings. That would be my experience. So I think it does enrich human life, and hopefully it helps enriching animals' life if through these processes we are able to design technology that serves them better, that is more animal centered.
Okay. So perhaps one more question before we wrap up. The ACI community has strong views on animal ethics. And of course, some of the members of ACI believes animals should be thought of as participants of the design process and as individuals. Some even say, hey, you do intensive farming, which may fall under the category of not so ethical. Perhaps you should look at alternate ways. Today in the morning, first speaker, Dr. Marianne Dawkins, she clearly said, hey, for cows and pigs, at least there is a possibility for individual care. But when we look at the birds, the poultry birds, we still do flock level management. Welfare is basically individual thing. It's not a group level thing. And Dr. Boyvin, our second speaker, he mentioned, before the cow has to start grooming herself, she has to engage with the button to activate the brush so that the brush starts rolling. She can go closer and rub and groom herself. So there is a need for the ability to, for the cow to engage in terms of designing buttons. So that gives the cow a choice and study its preferences. But from the animal welfare perspective, some may even say, hey, it's fantastic, the pet animal, companion animals, you do really nice research, but the number of animals you do is very little, few animals you do. So as Dr. Stacey pointed out, how do we go about scaling it up? Maybe I could ask this question in a way, what are the challenges of adapting and adopting the innovations developed in companion animals to farm animal sector, and how do we overcome the challenges? Because there is a dire need to bring these two communities, animal welfare biologist community and the ACA community, so that we can really create new ways of developing solutions for farm animals.
Yeah. Well, I think that when you design, there was a really nice example of the cow actioning the scratcher, the groomer, the grooming sort of role. And I think what a nice thing that she has to go and interact with the button, because she exerts her agency that way, and she controls her environment in that sense. That's a sort of a way in which she can take an action that is functional and purposeful. The key is, of course, how you design the button so that it is cow friendly, that is cow centered. And so, but when you design the button, you don't need to work with thousands of cows. Like when you design a new, like a computing application for humans, you work with a limited number of humans, and you develop your design as best you can, and then you deploy it. And when you deploy it, it can be used by thousands and millions of human users. And it seems to me that you could do something similar when working with farm animals. You are not going to necessarily work with thousands of animals to develop the one interface or the one piece of technology. But you do need to work with some, if it is for cows, you need to work with cows. If it is for sheep, you need to work with sheep, etc. What you can export from one domain to another is the approach, is the method. So you need to do an analysis. What are the biological characteristics of this animal? What are the characteristics of the environment in which the animal lives? What are the activities in which the animal engages? And all of this has to feed into your initial sort of design thoughts. And then you have to do lots of prototype of design, coming up with design concepts, prototyping, evaluating, more prototyping. As I was saying, it's an iterative process. And you may never get to the perfection, but with each iteration, you make improvements. So, and that's sort of the development stage. And then once you have something that you think, okay, and now, well, latest evaluation, this actually does, well, the animals engage willingly, they are easily, they can easily interact with these to obtain the outcome that is expected. Then you can deploy, then you can sort of roll it out. And there are techniques, there are ways of starting your design process so that you are already quite ahead of the game, so there is a process there that you can easily apply to designing with any animal. And so that would be the way of scaling up. The problem with designing at individual level or flock level, designing solutions for the different animals, that is a slightly different thing. We are talking about detection in that sense. So there is, I was saying there is data gathering, there's different aspects here, the intangible aspects, the tangible aspects. There is a interaction that individual animals have with the environment. And you can do that at individual level. You can provide interactive applications that even small animals living in a close quarters can interact with. You can do that. But in terms of detecting the different states of animals, and sort of by collecting data and feeding it to an algorithm, to sort of using machine learning to figure out what's going on with that is more challenging, because the system these are systems that are trying to interpret the data that you collect on a grand scale, and they're trying to first of all recognize the individual animals. When you have lots of small individual animals who look more or less all alike, that is a challenge for for any, for even for artificial intelligence. But so that will hopefully these systems, the technology here, these will develop to such level of sophistication that they will be able to recognize the individual animal, and will be able, to then feed into applications that then can perhaps provide suitable interactions for the individual animal. It's a case of how sophisticated the technology is at the moment, and how we hope that it will become in the near future.
Right. Are there any other questions from the audience? Well, seeing none, perhaps it's time for us to wrap up our morning session. Well, let's give another round of applause to Dr. Mancini. It's really, really intriguing and thoughtful. Thank you so much for making time to come to this webinar and share your experiences. It's very insightful for us. Thanks a lot.
Thank you.